Good morning, guys. So, I hope you could do a lot of questions from the sum because I think I have covered a lot of questions, right? At least the basic of it, right? So, let's move on with the laws of motion, right? So, today we'll start with the new topic which usually children like, which is friction. And I'm extremely sorry for the disturbance in the audio, can't help it, right? So friction, what is the definite, or what is the friction's definition? It is an opposing force, right? That is, actually, if there are two masses, let's say A and B, like this, right? Sorry, I wrote A itself now. A and B, if there is a motion of A on B along it in this direction, that means there is a relative motion of A, right, with respect to B. So there exists a force in between the surfaces of AB, or I can say friction is a contact force which opposes the motion of A, right? That is a force which opposes the tendency of relative motion, or a force which opposes the relative motion is known as friction, right? So friction is usually suffixed as Fr, right? So this, in the same example as the A and B, I can say if A is moving in this direction, that is in the forward direction, so there will be a friction on B by A, right, which will be in this direction, that is on B by A, right? Because, okay, I will talk with the simpler terms. That is that, let's say, friction which is applied by B on A, that is, what will be the direction of friction on A due to B? In this direction, because A is in this direction, so B, so the friction should be opposing it, right? So this will be the friction, right, on A due to B. Clear? Simple. Now similarly, suppose when A is moving in this direction, a person who is sitting in this block A will feel that B is moving in this direction, so a friction will be generated on B due to A, that will be in this direction. This is the meaning, right? So friction is always opposing the motion. Clear? This is not the proper way, but I was just introducing friction. Clear? Now that means you have to detailedly study about friction, and friction is there two types. Actually, there is rolling friction, which we will talk about later on. That is static friction, right? I can say. Then kinetic friction, and there is a sliding friction, but sliding friction comes in kinetic friction itself. Now what is static friction? A friction which comes up when the object is not at all moving, or I can say when the body is at rest, right? There is a motion is not happening at that time. See, suppose there is a block like this. I am applying, let's say, it's a heavier object. I am applying a very small force, very less force, let's say F, small f, right? And the block is not moving. Why? But I have done some force, I have applied some force, yet the block has not moved. That means there has been some opposition. That opposition, due to which the object is not able to move, right? Even if the force is applied, this force is known as, so this opposing force in the surface of contact is known as static friction, right? That I can say, that means the frictional force is very greater than applied force, right? The frictional force is greater than applied force, right? That's why the block is not moving. Then what do you mean by kinetic friction? That is, suppose the object is moving, I applied a larger force, right? So if it is, suppose it is a stand, or I can say very rough surface, the object will be moving, but you will be feeling an opposition, that it will not be that as smooth as you are moving that object on a frictionless surface or a smooth surface, right? That friction which happens when, or which is appearing in the surface of contact when the when I say when the object is netly moving, is known as kinetic friction, right? Static friction when the object is not moving, kinetic friction when there is object is moving. So static friction is little bit difficult, so we'll talk about kinetic friction in detail first, then we'll move on to static friction. So kinetic friction, when I say about it, Fk, right? There is a representation usually 10. It's a relative. It happens when there is a relative motion, right? When there is a motion of an object over another surface. So that's why we talk it as, or call it as, relative motion. and it is a constant one. Keep that in mind. It's a constant one because that is Fk is constant, right? So if this is constant, that means that is Fk is constant means am writing this, you have to by heart. Kinetic friction is directly proportional to normal reaction. Mug it. Right, that is, if there is an object like this, it is having a normal reaction weight here. So suppose the object is trying to move in forward direction, the kinetic friction will be in this direction, and this kinetic friction is proportional to normal reaction. Why? Friction is provided by the surface of contact. That surface of contact is giving you the normal reaction, right? That's why Fk is proportional to n. Or I can write, in order to remove this proportional value, I can write Fk is equal to mu k into n, where mu k is known as coefficient of kinetic friction. Mu k is coefficient of kinetic friction. I am extremely sorry due to the disturbance. I am highly disturbed, no other way. Right, I'm increasing the volume for maximum. Don't listen to the voices which are in behind. I cannot ask him to stop yelling, right? Okay, so now, okay, there is another point we have to talk about in the case of what kinetic friction, that is the direction, right? It will be always in the opposition. That is, if the motion is happening in this direction, then the friction will be opposite to it. So the direction is such that it opposes the relative motion. Clear? Right? So see, don't expect me to write the entire sentence, guys. You guys can make it from here. Right? So write the sentences by yourself. We'll start with the problem. Right? So this is the blah, blah, blah surface. You're having a 4 kilogram block, let's say, and you are trying to pull it by 10 Newton. Let's say there is a coefficient of friction is given for kinetic friction, and you're told that the object has moved. Okay, the object is moving, right? So you're asked what is the frictional force, and also asked what is the acceleration. So how would you do? You obviously you have to draw the free body diagram. This is 4 kilogram means mg, that is 40, right? That is 4 into g. Downwards there will be normal reaction in this direction. Now since 10 Newton is in this direction, the Fk will be in this direction, right? Obviously the pull, because kinetic friction is opposing the motion. So what is Fk? We have taken it as mu k into n. Now what is n? N is equal to 40, right? Because that is a vertical force. So mu k is taken as, how much did you take? 0.2 now. So 0.2 into 40, or I can say 8 Newton, right? Right, that means if I draw this, or I can just rub it off now. That means in place of Fk, I am not going to write here 8 Newton. Right, so in this block case, 10 Newton is forward, backward there is a force of 8 Newton. That means net force, external force which is acting as 2 Newton. Right, so acceleration is net force divided by mass. How much is the mass, guys? 4 now. So 2 by 4, or I can say 0.5 meter per second squared is the acceleration of the block. I found two answers. Right, simple. Right, this and all kinetic friction is very simple, man. Right, you just have to use the equation. We'll do a little bit change. The second level I can say about the question same. 4 kilogram, right? Suppose a force 10 root 2 is there, right? So that is at an angle 45 degree with the horizontal, right? And let's say the coefficient of then select and the coefficient of friction mu k is known as 0.3, right? And the object is moving, that is given. You are asked what is n, what is kinetic friction, and obviously you are asked acceleration. So how would you do it? So obviously you have to draw what is known as free body diagram. So there is a 40, right, 4g, and there is normal reaction, right? Now this force 10 root 2, I can resolve it into two components. This is 10 root 2 cos 45, which is 1 by root 2, right? And this is 10 root 2 sine 45, or I can write it as 1 by root 2 itself. So root 2 cancels, root 2 cancels, right? That means here I can write just 10 Newton here, right? And here also 10 Newton. Clear? Now you can remove this force also, because you have already resolved it into its components. Now how would you calculate now? Finish? No. There is a kinetic friction, right? The relative motion you are told in this direction, that is acceleration is this direction, right? So this is Fk, right? So from this figure, what you know, what is Fk? Fk is mu k into n. Mu k is given, but you don't know the n's value. How can I find n? You can get from this picture itself, right? So this 10 is in this direction now. So n plus 10 is equal to 40, right? Or n is equal to 30 Newton, right? Now use that value here. Fk, mu k is 0.3 and n is what? 30 Newton. You will get 9 Newton as frictional force. So that is this much force is pulling that object backwards and 10 Newton is pulling it forward, right? 10 Newton is pulling it forward, right? So what will be the acceleration? Net force, it will be 1 Newton divided by mass. How much is the mass? 4 kilogram. That is acceleration. That is 0.25 meter per second squared is the acceleration. Clear? Right? Now, I told you this and all is very easy. Now, because you just asked what is the frictional force, you just have to resolve it, right? Now, the problem comes up if you are asked regarding static friction, or you are combinedly asked questions, right? So you have to understand static friction properly. See, static friction happens when the object is not moving, or I can say it is having just a tendency to move, right? That is, it has tendency to move, right? It wishes to move, but it is not possible, and it is not constant, guys. It is not constant. It depends upon how much you are applying force, right? Depending upon that, it will change. Low force means low friction, static friction. High force means higher static friction, right? Or I can say there is a term called limiting friction, right? After that is, so I will say that is the static friction lies between 0 and the maximum is limiting friction, which is I have written as FL. That is, see, suppose this is a block, right? I applied 10 Newton, right? Then the friction force, let's say the static friction is, or the limiting friction is 10 Newton, means this is the limit of the friction which can be applied by the object so that the object doesn't move. That is on the brink, right? On the brink of the non-motion, or the brink of the resting motion. That is, if you just apply 10.5 Newton, now this block will move. Obviously it moves because the limiting friction has crossed. So maximum static friction, that is known as limiting friction. That is after the friction static, that is, I can say after the limiting friction is crossed by the applied force, the object can easily move, right? That is, if there is a 4 kilogram block, right, and I am applying a force, let's say 6 Newton, and I am telling you there is a mu s, right? Mu s is a static coefficient of static friction, let's say 0.2, right? So if the friction, right, if I can say the limiting friction, if I calculate, I will tell you the equation, I'm just telling you, if the limiting friction is 4 Newton, let's say, right, that means if you apply more than, that is, it can tolerate, right, the friction can oppose till 4 Newton. Which friction? Static friction can oppose till 4 Newton. If you apply more than 4 Newton, that means the object will move, but there will be an opposition, but not by static friction, but by kinetic friction. Yeah, I hope you understood, right? Clear? So the in your textbook, etc., static friction itself is written as limiting friction, but basically it is different, because static friction can be 0 to like that, and it increases to maximum value. So maximum static friction is known as limiting friction. That is the friction which is maximum, statically maximum, that at rest maximum friction is known as limiting friction. After the limiting friction is crossed, then the friction changes into kinetic friction. Clear? That is, മലയാളത്തിൽ ഞാൻ ഇടയ്ക്ക് പറയാണ് കേട്ടോ, അത് വൃത്തിയായി മനസ്സിലാക്കണമെങ്കിൽ മലയാളത്തിൽ തന്നെ പറയണം. അതായത് ഒരു വസ്തു ലോക്കായി, ഒരു വസ്തു എനിക്ക് ഇങ്ങനെ ഉണ്ടെന്ന് വിചാരിക്കാം. അതിന് അത് റെസ്റ്റിലായിരിക്കുന്ന സമയത്ത് ഞാൻ 2 ന്യൂട്ടൺ കൊടുത്തു കേട്ടോ. അപ്പോൾ അതിൻ്റെ സ്റ്റാറ്റിക് ഫ്രിക്ഷൻ നോക്കിയപ്പോഴേ 8 ന്യൂട്ടണാണെന്ന് വിചാരിക്കുക. അതെൻ്റെ ലിമിറ്റിംഗ് ഫ്രിക്ഷൻ അല്ല കേട്ടോ. 2 ന്യൂട്ടൺ കൊടുത്തു, 8 ന്യൂട്ടൺ ഒപ്പോസ് ചെയ്തു, അതെൻ്റെ സ്റ്റാറ്റിക് ഫ്രിക്ഷനാണ്. അതിൻ്റെ അർത്ഥം സപ്പോസ് ഇതിൻ്റെ 10 ന്യൂട്ടൺ ആണ് ലിമിറ്റിംഗ് ഫ്രിക്ഷൻ ആവണം. ക്ലിയർ ആവണ്ട? ഒന്നുകൂടി ശ്രദ്ധിച്ചു നോക്കിയേ. മലയാളത്തിൽ പറയണത് വൃത്തിയായി മനസ്സിലാക്കാൻ വേണ്ടി മാത്രമാണ് കേട്ടോ. ഇനി അതിന് പ്രശ്നം ഉണ്ടാക്കല്ലേ. ഇത് നമ്മുടെ കയ്യിൽ ഒരു ബ്ലോക്ക് ഉണ്ടെന്ന് വിചാരിക്കാം. ആ ബ്ലോക്കിൽ ഞാനൊരു ഫോഴ്സ് അപ്ലൈ ചെയ്തു വിചാരിക്കാം. ആ ഫോഴ്സ് എങ്ങനെയെങ്കിലും ആയിക്കോട്ടെ. ഇതിൽ റെസ്റ്റിലായിരുന്നു വെച്ചാൽ ഇതിന് റെസ്റ്റിലാക്കിയിരുന്നത് ഒരു സ്റ്റാറ്റിക് ഫ്രിക്ഷനാണ് വെച്ച് കഴിഞ്ഞാൽ അതവിടെ നിന്നിരുന്നു. ഒരു ഫോഴ്സ് ഇല്ലെങ്കിൽ അപ്പോൾ അതിൻ്റെ അർത്ഥം ഫോഴ്സ് ഇല്ലെങ്കിൽ സ്റ്റാറ്റിക് ഫ്രിക്ഷൻ ആക്ട് ചെയ്യേണ്ട കാര്യമില്ല. അപ്പോൾ ഇത് 0-ലാണ് നിന്നിരുന്നത്. അപ്പം ഞാനൊരു 3 ന്യൂട്ടൺ കൊടുത്തു. അപ്പോൾ അതിനെ അപ്പോസ് ചെയ്യണത് രീതിയിൽ നീങ്ങാതിരിക്കാൻ വേണ്ടിയിട്ട് 3 ന്യൂട്ടണിൽ തന്നെ ഇരിക്കുന്നത് ഫ്രിക്ഷൻ നടത്തിയിരിക്കുക, സ്റ്റാറ്റിക് ഫ്രിക്ഷനെ ആയിരിക്കാം, റൈറ്റ്. അപ്പോൾ എന്നിട്ട് പക്ഷെ ഞാൻ പറയാണ് ഈ വസ്തുവിൻ്റെ സ്റ്റാറ്റിക് ഫ്രിക്ഷൻ 0 തൊട്ട് 10 ന്യൂട്ടൺ വരെ പോകുള്ളൂ. അതിൻ്റെ അർത്ഥം ഈ 10 ന്യൂട്ടനാണ് ആ സ്റ്റാറ്റിക് അതായത് ആ സ്റ്റാറ്റിക് ഫ്രിക്ഷന് നൽകാൻ പറ്റാവുന്ന മാക്സിമം വാല്യൂ. ഈ 10 ന്യൂട്ടനെയാണ് ലിമിറ്റിംഗ് ഫ്രിക്ഷൻ എന്ന് പറയാം. ക്ലിയർ? അപ്പം ഞാൻ കൊടുക്കുന്ന ഫ്രിക്ഷൻ 10 ന്യൂട്ടണിലേക്കാൾ കൂടുതൽ 15 ന്യൂട്ടൺ ആയിക്കഴിഞ്ഞാൽ ഇനി വസ്തു നീങ്ങുമ്പോൾ സ്വയമായിട്ട് നീങ്ങുന്ന വസ്തുവിലുണ്ടല്ലേ ഫ്രിക്ഷൻ. ആ ഫ്രിക്ഷനെയാണ് ഞാൻ പറയാം കൈനറ്റിക് ഫ്രിക്ഷൻ. ക്ലിയർ? സോ വെൻ യു ടോക്ക് അബൌട്ട് static friction, usually it is just considered into limiting friction itself in your textbook. പക്ഷെ ഞാൻ അതിൻ്റെ കറക്റ്റ് പറഞ്ഞതാണ്. അപ്പോൾ there is an equation for limiting friction which is μs into n. mu k എന്തായിരുന്നു? mu k into n അല്ലേ. fk is equal to kinetic friction എന്തായിരുന്നു? mu k into n. എന്നാൽ ലിമിറ്റിംഗ് ഫ്രിക്ഷൻ ഓർ സ്റ്റാറ്റിക്കലി ലിമിറ്റിംഗ് ഫ്രിക്ഷൻ എന്താ? mu s into n. ക്ലിയർ ആയ? ഇപ്പോൾ നമ്മുടെ കയ്യിൽ അതായത് ഇപ്പോൾ അപ്ലൈഡ് ഫോഴ്സ് ഇഫ് ഇറ്റ് ഈസ് ഗ്രേറ്റർ ദാൻ ലിമിറ്റിംഗ് ഫ്രിക്ഷൻ ഇനി ഒബ്ജക്റ്റ് നീങ്ങിത്തോളം അല്ലേ. ഇഫ് ഇറ്റ് ഈസ് ഇപ്പോൾ ഈ ഓപ്പോസിങ് ഫോഴ്സ് അല്ലെങ്കിൽ അപ്ലൈഡ് ഫോഴ്സ് ഇപ്പോൾ സ്റ്റാറ്റിക് ഫ്രിക്ഷൻ ഉണ്ടല്ലോ, മാക്സിമം സ്റ്റാറ്റിക് ഫ്രിക്ഷൻ ഈക്വൽ ഉണ്ടാകുന്ന വെച്ച് കഴിഞ്ഞാൽ ഈ FSന് ഈക്വൽ ഉണ്ടായിരുന്നു എന്നാണ് വസ്തു അങ്ങനെ തന്നെ ഇരിക്കുക കേട്ടല്ലോ. ഇഫ് ഇറ്റ് ഈസ് ഗ്രേറ്റർ ദാൻ ലിമിറ്റിംഗ് ഫ്രിക്ഷനിൽ മാത്രമേ ഒബ്ജക്റ്റ് നീങ്ങുള്ളൂ. അത് മനസ്സിൽ വിചാരിച്ച് വെച്ചിരിക്കുക കേട്ടോ. ക്ലിയർ? റൈറ്റ്. സോ വൺസ് അത് മൂവ് ചെയ്ത് തുടങ്ങിക്കഴിഞ്ഞാൽ ഇത് ഫ്രിക്ഷൻ ആക്ട് ചെയ്യാം. അപ്പോൾ ലിമിറ്റിംഗ് ഫ്രിക്ഷൻ ആക്ട് ചെയ്യും. ഇനി ഞാൻ ഇംഗ്ലീഷിൽ പറയുന്നില്ല, മലയാളത്തിൽ പറയുന്നില്ല കേട്ടോ, എനിവേസ്. സോ ദിസ് മച്ച് ഇക്വേഷൻ ഇസ് ക്ലിയർ, റൈറ്റ്. സപ്പോസ് എൻ്റെ കയ്യിലൊരു 2 കിലോഗ്രാം ബ്ലോക്ക് ഉണ്ട് ആൻഡ് ഐ എം അപ്ലൈയിങ് എ ഫോഴ്സ് ഓഫ് 20 ന്യൂട്ടൺ. ലെറ്റ്സ് സേ 2 വാല്യൂ തന്നിട്ടുണ്ട്. മ്യൂഎസ് റിപ്പീറ്റിംഗ് ഓക്കെ 0.6 ആസ് വെൽ ആസ് യു ആർ ഗിവൻ mu k is equal to 0.4. Right, you are given 2 values. Right, so you are asked will this object move? If it is moving, right, with how much force or how much is the friction? So how would you do it? Right, so this is 2 k means I meant it is 2 kilogram, right? So obviously you have to see whether the object will move or not. So you are having a 2 kilogram block, right? So I can resolve it. This is n and this will be 20 newton in the 2g, right? 20 newton will in the downward direction and this 20 newton in the right direction. So friction will be in this direction. I don't know what type of friction it is going to be, right? Let's first always find the static friction, or I can say FL, limiting friction. I have to know whether the applied force has been more than the limiting friction. Let's say it is mu s into n. Mu s is how much? 0.6 and n is 20. So you will get 12 newton, right? That means you have applied 20 newton. The friction which is pulling it back is only 12 newton. So the object will move, right? Yes, that means now the friction which is acting is not limiting friction. We have checked it whether it will be moving or not. So and the friction which is pulling it out in opposite direction so that it doesn't move is only 12 newton. So applied force is greater than friction. So that means now there is a motion. If there is a motion, that means the friction acting is kinetic friction, which is mu k into n, that is 0.4 into 20 now. That is mu k into n, right? That is how much? 8 newton, right? That means 20 newton in this direction and 8 newton in this direction. If you want, you can find the acceleration. I don't think you require. I hope you understood. Yeah. Now there's a variety of questions which is usually asked and the kids makes a lot of mistake regarding it. This is a block, right? Let's say 1 kilogram, right? And you are applying a 40 newton in this force like this, right? And you are given coefficient of static friction as 0.3 and coefficient of kinetic friction as 0.2, right? This much is clear. right? And you are asked whether the object will move or not, and if they're just moving, or what amount of friction it is going to be. Now the common sense is very important, guys. Let me ask you, which is the applied force here? Is it 40 Newton? No. See, applied force means the force which is causing the motion. Here the motion causing force is weight, 1g. That is what is going to cause motion. 40 Newton is not going to cause motion, it is pressing it, right? So I can say this just like a ball and you are pushing a book over it, right? So that means what is pulling it, or what is causing the motion? It is a downward motion, which is 1g. Clear? So friction will be acting in this direction, right? That is opposing the cause or motion. I don't know whether friction is static or kinetic. So always, just like the previous one, we will find whether the object will move or not. That means I have to find how much is the opposition which is given if that was a static condition. So mu s into n, that is 0.3 into n. How much is n? I don't know. It is easy. See, let me rub here, right? If you are pushing it in with 40 Newton, then equal and opposite reaction, n will be 40. So it will be 40. So it is 12 Newton. That is the limiting friction, right? So 1g means it is 10 Newton. No? Simple. So that means the friction which is pulling back here is 12 Newton if it is static itself, right? So that means the applied force in the downward friction or downward direction, if it had been greater than 12 Newton, then that means the weight, if it had been greater than 12 Newton, the brick would have fallen, but it is not, because the friction which is pulling it up is 12 Newton, which is the static friction itself. That means there is no motion. Clear, right? If the weight, if this had been a 3 kilogram weight, then downward will be 30 Newton, no? So that means there will be obviously a motion, because 12 is less than 30. So static will not act, but kinetic will act. That's 0.2 into 40, right? 0.2 into 40 will be there. That is how much? 8. 8 Newton will be the opposition. I just tell you or told you as it is. Clear? This much is clear, right? Now, friction is very important, guys. This chapter main section I can say is friction. Right, now the next section which you have to know is angle of repose, right? Or you can write it as theta r, right? This is a neat topic. It is better if no, I think you guys can learn it for in a common way. See, this is your block, right? See, so if you're suppose if there is a limiting friction, right? That's a very hero, right? Suppose the object is just going to move, that means there is a static friction, and just going to move means the friction which is happening is limiting friction. If that is achieved, or more than limiting friction is achieved, means the object will be moving, right? So the object is just in the brink of going to move, and there is a normal reaction, right? So there are two forces, right? So there will be a resultant, let's say that is R. This is a resultant contact force. This R is resultant contact force. This angle theta is known as what? Angle of repose. That is the angle made by the resultant contact force with the normal, right? And what is the resultant contact force? That is the resultant of limiting friction and normal reaction, right? Clear? This is a neat topic actually, but I am just telling you. So if you are asked what is theta, you can extend this as triangle. This will be FL now, right? So that means tan theta is equal to FL by N, right? This triangle like this. So this is N, right? This is R, and this is FL, and this is theta, right? So we will find what is FL and N reaction. Tell me. FL is what? Mu S into N, limiting friction, and there is N in cancel, or I can say tan theta, right, is equal to mu S, or I can write theta R is equal to tan inverse mu S, just by heart this equation. That is angle of repose is equal to tan inverse coefficient of static friction. Clear? Right? Now the next topic which we have, this all are coming in the same topic as the friction. That's why I am taking it in a single section. that is inclined plane. Some of the things we have learned in the inclined plane, right? But those are the sections from what our smooth plane. Now we are going to consider a rough inclined plane, right? This is a rough inclined plane. Let's say there is a block here, right? And let's say there is a theta angle here, right? So this will be mg, right? And this was, I hope you remember, I wrote it as mg cos theta, and this will be mg sin theta, and there will be a normal reaction. This is the condition when you learned about inclined plane in the case of smooth condition. Now I told you this is a rough plane, right? So there will be, obviously there will be a friction this direction. Why the friction is in this direction? Normally the object tends to move in this direction, right? So what can I write? Means we have not come into the details, guys. I'm just giving an introduction. So maximum friction, right? Maximum friction so that the object doesn't move. Maximum friction when so that the object doesn't move is known as limiting friction. That is equal to mu s into n, right? So what is mu s? You just write it as mu s. So if it is given, so substitute it. What is n? N is equal to, see the same line, n is equal to mg cos theta. So that is limiting friction, right? Now that means this is the force, this is a frictional force which doesn't allow the object to slide over the rough inclined plane, right? And what does the one, or what is the force which is pulling it down? This one. There is a force which is pulling it down is mg sin theta. This is clear from the figure, right? The one which is pushing it up, right, which doesn't allow is this force, which is mu s mg cos theta, and which is pulling it down is mg sin theta. Clear from the figure, right? Let's move on. Now something which have to, or something which you have must have learned in mathematics. When when theta is very small, you can see that sine theta will be very small, but cos theta will be large. See, look at all the angles you see. Sine theta values will be less when theta is less. Whereas when theta is greater, cos theta will be less, whereas sine theta will be greater. Just look into the equations, guys. Look into the values. That's a common thing, right? That's why when you say that initially, why the, no, suppose the angle, see, when the angle this theta is very less, the block will not fall. But when you increase the angle, the block falls off. Why? When you increase the angle, right? When you increase the angle, that means cos theta is less now. So mu s mg cos theta, which opposes the fall, is less, right? When the theta is less, that is in this condition, sin theta is less and cos theta is greater, that is this factor, that is the frictional force which is pushing it or pulling it outward or into the, I can say above, on the forward direction, this direction, right? That is high. That's why the block is not falling. It's just an extra thing I'm telling, right? That means the theta plays a very important role, right? So why the sliding section block is not falling by itself? When the limiting friction is higher, just like the previous case, right? So maximum angle, the which by which a block can stay at rest, that is actually angle of repose, right? That is the maximum angle, right? Let's say this is the maximum angle, that's right, right? The maximum angle, right, by which the block can stay at rest. If you have an angle greater than angle of repose, then the block will fall, right? Clear? And you remember what is angle of repose? It is tan inverse mu s, right? So there are two definitions for angle of repose. One is the angle made by the resultant of contact forces with the normal, and the other is the angle, minimum angle, right? Or sorry, the maximum angle by which the block can stand or stay at rest on a rough inclined plane. If the angle is increased than the or is more than the angle of repose, it is definitely sure that the block will fall, right? So we can make a table like this. If the angle less than angle of repose, there is no sliding, right? And that means the block is at rest. That means static friction is acting, right? right? That static friction is equal to the applied force, no motion, right? When the angle is equal to angle of repose, that means it is not moving, but it is has a tendency to move, right? That means what friction is acting? Limiting friction has acted, that is mu s. Obviously it is at rest, right? Similarly, if the angle is greater than angle of repose, now the sliding is happening, right? I can say now the friction which is acting is kinetic friction, which is equal to mu k into n. We can make an angle like this, right? Clear? Now, now we'll move an angle. Suppose this is your inclined angle, let's say, and there is a 30-degree here, there is a block here, let's say M, right? And suppose you are given that the angle of repose is 45-degree, right? And you are asked whether the body is at rest or in motion, and you are asked whatever the case may be, what will be the frictional force and what will be the acceleration. Clear? So first you look, the angle of repose is 45-degree. That means if the angle is greater than 45-degree, only the block will fall. Let's see what is the angle here, inclined plane for 30-degree. 30-degree, that is angle is less than 45-degree, right? When angle theta is less than theta r, the friction which will be acting is static friction, right? And static friction will be equal to applied force, right? Clear? Right. So here mg, that will be here mg and here mg cos 30-degree, right? And here it will be mg sin 30-degree, right? Now which is the motion force which is causing motion? This one. And you are told the static friction, that is, this is the applied force, right? That is what causes the force, motion. That means the static friction will be equal to mg sin 30-degree, right? That is mg by 2. Clear? And you are asked what is acceleration. See guys, it is not moving, it is at rest, right? That's why the friction is static friction. There is no motion. If there is no motion, there is no acceleration. That is, acceleration is equal to 0. Simple. Now we will make it a little bit complicated. Yes. Right. Let's say this is our inclined plane. Let's say 45 degrees is given, right? And let's say there is a block M, right? Clear? And you are asked whether it will slide or not, right? And let's say the angle of repose is given as 37-degree. Now it is clear it is moving to move, right? What is the angle here? 45-degree. So theta is greater than theta r. That is, angle of plane is greater than angle of repose, right? That means there will be sliding, right? And it moves. It is not equal. It moves means there will be kinetic friction acting. That's much clear. Now let's draw the free body diagram. This will be mg cos theta or cos 45, la? Cos 45, mg cos 45-degree, right? And here will be mg sin 45-degree, right? And obviously it is going to move means there will be an acceleration in this direction, and obviously there is normal reaction here, right? And the frictional force which opposes the motion is kinetic friction, which is mu k into n, right? Clear? Now Fk, I am writing here itself, Fk is mu k into n, right? I don't know the value of n, but we can look into the figure and can find that n is equal to mg cos 45. That means Fk is equal to mu k mg cos 45-degree. This is the kinetic friction. You are asked whether the body will move. Yes, it is moving, it is sliding. That is the first part. The second, what is the kinetic friction you have found. Now the next question comes, what is the acceleration? How would you do it? Again, look into this diagram itself, guys. That means the object is moving in this direction, huh? Right? So that means this factor is higher, that is mg, that is positive, mg sin 45-degree, right, minus Fk, right, minus Fk is equal to ma. In place of Fk, you can write it as mu k mg cos 45-degree is equal to what? Ma. You can cancel m in all the conditions. So I can write a is equal to, here g sin 45 will be what? G by root 2, right? Right, 1 minus mu k. Why did I write cos 45 and sin 45 as same value as 1 by root 2? Right? You will get the value of this one. Simple. If you don't make it as complicated, it is very easy. Right? Clear? Let's make, suppose there can be a condition when you are not given the angle of repose. Right? So you have to find that also. Suppose this is the inclined plane. You are having a block like this. Right? Let's say here on nothing has been mentioned whether it is static coefficient or kinetic friction coefficient. Let's say it is 0.75. Right? So, and you are told it is moving downwards with an acceleration A, let's say. Right? So obviously how would you, and suppose this is angle 53, that is inclined plane's angle is taken as 53. So how would you find angle of repose? You know theta r is equal to tan inverse mu s, but you are not specifically given, so you just write mu itself. Right? So tan inverse 0.75 means tan inverse 3 by 4, that is 37 degree. Right? That is angle of repose. Now tell me whether the body will accelerate down or not. Yes, it will be accelerating downwards because here the inclined angle is 53 degree, which is greater than angle of repose. When theta is greater than theta r, there is what? Kinetic friction acting. So the kinetic friction will be here in this direction. Here, remember it was mg sine 53 degree. Here it will be mg cos 53 degree. And here it will be normal reaction. Then you have to quit. I'm not going to tell you how to find the friction and acceleration. We have done it. Clear? Right? I have written the question first itself because it's difficult to do it in different parts. So suppose this is a 6 kilogram block on an rough inclined plane like this, and you are given coefficient of static friction and kinetic friction as 0.6 and 0.4, and you are applying a force in upward direction. You are asked what is the force? Right? When each and every question you have to do. First, we'll do the first one. When the block is stationary, that is, you have to apply a force that the block is stationary. That means it intends that the block is already moving. You have to apply an external force along with the friction which is existing. Obviously, there is a rough surface, there will be a friction, right? Above that friction, you have to apply a force so that you can stop the motion of the object which had been naturally moving downwards. If you don't understand, I will repeat it again. Suppose there is no friction here, right? So that means there had been a friction here. That is no force applied, and by its sine theta component, it was supposed to move downwards, and it had been moving. Right? So that means along with this friction, I have to give a force so that now the block doesn't move. That is the meaning. Right? So you are asked how much force I have to apply so that now the block doesn't move. This much clear? So let's move on with the first question. So how would you do it? Remember this figure itself, I'm going to write here F, and there is a frictional force Fr, and what will be here? It will be what? Remember mg sine theta. They are 6g sine 60. Right? Clear? See guys, I'm not going to write the entire thing. We have repeatedly written that along this inclined plane, the component will be mg sine theta, and along opposite to the normal will be mg cos theta. We have repeatedly done it. So here I can write from the figure itself, F is equal to Fr, right, is equal to 6g sine 60. This much is clear from the figure. Now tell me, what type of friction it should be? I don't know, right? So we don't know whether it is static or limiting because I don't know whether it had been moving. Suppose they have not mentioned that it has been moving, right? That means let's say that best one friction which is supposed to taken is limiting friction. We can say whether it is moving or not. It will be mu s into n, right? What is mu s? That much value we can find. That's let's leave it. N is what? Mg cos theta. That is 6g cos 60 degree. Right, and what is mu s? Let's write mu s as how much? 0.6 now. So it is 0.6. You will find the value as 18 Newton. Right, clear? Right, so 18 Newton is what? Only limiting friction. This much friction if it had been 18 Newton. Let's say what is 6g sine theta? So sine 60 degree it is how much? I believe it is 52 Newton. It's around 50 Newton. You can do the calculation, right? So here opposition is only 18 Newton. Here the one which is moving due to the weight is 52 Newton. Tell me if it moves or not. Obviously it moves. Right? Clear? So initially the block was moving. Right? So initially the block was moving with 54 Newton in this direction, with how much Newton here? 18 Newton by the limiting friction. Because we can only talk about limiting friction, we cannot talk about our kinetic friction. Right? Clear? So how much force I have to apply that it stops? Now you guys might be asking me, you told that initially the object had been moving. So obviously the force which is, friction should be have been what? Kinetic friction. See, listen to the question. You have to stop the object, right? So if an F, let's say, has been applied, so then the object will become at rest. Then there should be what friction? Then that should be a what? Static friction has to act, or I can say limiting friction has to be done. Don't look into the previous condition. You have to think about now. Now you have to give a force. F is given, it is stopped. Stopped means now you are having a limiting friction there, that is 18 Newton. So what is the force here? Force will be 54 minus 18, that is 34 Newton. Right? Now the object is at rest because 54 Newton in this direction and 34 Newton applied force and a static friction, or I can say limiting friction of 18 Newton, because now it is at rest. Now it's simple. Clear? Understand the meaning of the question. Now the same question, I have done a lot of writing on it now. 6 kilogram, 52 here, right? Force has to be applied here for the second condition, that is the block has to move with constant velocity. Constant velocity means acceleration is 0. Keep that in mind, right? So when the object is moving with constant velocity is given, means now you have to think about which friction? Kinetic friction, which is Fk is equal to what? Fk is equal to mu k, that is mu k is what? 0.4, right? You can just write it as, I will tell and you can understand, 0.4 into n, that is mg, or I can say it is 6g, 6g cos 60. We have found for that value earlier. So it is around what? How much? I believe it is 30, right? So you will get 12 Newton here. Fk will be 12 Newton here, right? 52 Newton in this direction, 12 Newton in this direction. What should be the friction, force applied so that the object is not accelerated at all? If you don't understand, I will tell it again, right? That means there is no acceleration in this or either direction. That means this force should be equal to this force. That is, this direction force should be equal to this direction force. That means this should be 40 Newton. Simple. Then only 40 plus 12 becomes 52 Newton here. Clear? Right? Then that means the object will not, it is at the brink of not accelerated motion. Clear? That the minimum force should be 40 Newton. Clear? So that the object will be moving by its own with a constant velocity. Clear? Not accelerated motion. Now same sliding, there is a brick. The same question, so third part now, when it is moving up with an acceleration 4 meter per second squared, right? How would you do it? If it is moving up, in which direction the friction will be? Friction Fk now will be 12 Newton. We have already found the value in this direction, right? And already there is a 52 Newton by its weight, and you have to apply a force in this direction so that the object moves with an upward direction. So I can write F is a positive, right? Because A is direction in the same direction. F minus what? This 52 plus 12 is 64 Newton is equal to MA, that is 6 into 4, right? Or I can say how much force I have to apply? 88 Newton applied, so that the object can move up with an acceleration 4 meter per second squared. Clear? It's very simple, right? This and all value we have already found. That's why I used it again and again. Clear?